I'm a front-end developer at GitHub. I've been a front-end developer for well over 8 years now. About 5 years ago when I joined GitHub, I started working with .NET from zero, literally zero knowledge in .NET. 5 years down the line, I'm an every service certified developer, occasional speaker at JavaScript LV, and I write at Nasir.com. So, being a front-end developer, I work a lot with like JavaScript, mainly front-end technologies, libraries and frameworks like jQuery and Angular, mainly jQuery and Angular. And I do a lot of .NET coding, and I'm working my way to becoming a full-stack developer. So, and then a bit about us. Well, more about like our vacancies. We are looking for new people. So Geta is a digital web agency. We specialize in e-commerce solutions. We have offices in, we are based in Oslo. We also have offices in Riga, in Sweden, in Amsterdam, if you guys are into that kind of thing. And then we have one in the US. Okay, and well, this is a list of people we're looking for. We're looking for .NET developers, front-end developers, we're really short on those, full-stack developers, and test engineers. Okay, so let's get into the presentation. I want to start with looking at where we are today with JavaScript. So JavaScript was created in May 1995 in just 10 days by Brendan Eich, who was then working at Netscape and now is working at Mozilla. And as you all are probably aware, JavaScript is here to stay. It's not going anywhere. And even if it was at first created as a scripting language, now it's so much more. We can find it everywhere, in the back end, mainly in the front end, but nowadays we have it in the back end, and also with for writing mobile applications. So Scott Hanselman said this. Calls JavaScript the assembly language of the web. And Jeff Atwood, does anyone know who Jeff Atwood is? He's a writer at Coding Horrors. And he says any application that can be written in JavaScript will eventually be written in JavaScript. And he's kind of right, I think. Yeah. So JavaScript is great. It's found everywhere, front end, back end with Node. And then you have mobile applications put over. But it still has its downsides, still had its problems. I'm saying past tense because that's kind of solved. One of which is, from my experience, the chaotic coding structure. And this is coming from a guy who's been working with front-end technologies for well over 8 years. But as of 5 years ago, I started working with .NET, and then I realized that, well, there's a better way of doing things. If you look at this example here, it's a very simple example. It's what is it? Is it a class definition, or is it a method, or is it a constructor? Anyone tell me? Well, it is just a class definition, but as you can see, it's very unclear as to what it is, just by this thing here, like a function. You have no idea what that means. It's just it's a function. Okay, fine. And then you have your method definition. And then you move on to extending a class, and you come up with something like this. Something as simple as extending a class takes up so much code. So you have shape, and now I want to create a circle, which is a subclass of shape. And you would have to do something like this, a circle, prototype, object, create, and so on and so forth. And then, only then, can you define the method for your subclass. Because if you did that, way up here, is going to get overwritten when you define your base class. Did anyone know that? Did anyone know that? So for me, this is extremely unintuitive. It's very confusing and honestly downright ugly. And then there's a question of the this keyword, the dreaded this. So I'm going to show you this piece of code. It's a small demo on Just Fiddle, and I just want to know what you guys think. Hopefully we have network. Yeah. Okay. So can anyone see? Yeah, everyone can see. Let me just. Okay. So who here thinks that this button is going to behave like it should, and that you'll get an alert box that will say, "Hello world." Oh, I guess you guys already know what's going to happen, because obviously there's a problem because I'm showing you this example, right? So yeah, you're right, and you're right. The alert box did show up, but nothing's inside. And it's mainly because the context of this within the event handler has changed. So unlike C#, this doesn't always refer to what you think this is. Because in C# always refers to the current class context. At least that's from my experience. But in JavaScript, this depends on where this is used. Yeah, very confusing. It's very confusing. It's not intuitive and can cause a lot of unexpected behaviors if you're not careful. And then after working with C#, a statically typed language like C#, you come to the conclusion that it's you can have a dynamic variable like in JavaScript, but it's probably better to separate those, so that you can't do something like this. You have a variable that starts life as a date and ends up being a string. So in JavaScript, a variable can be anything, or it can simply be nothing, if left undefined, of course. And then along came ECMAScript 6, and we thought like, yay, everything has been solved. Well, actually, that's quite true, because ECMAScript 6 solves most of the problem plaguing JavaScript today. They introduced the classes, constants. Let's call this through the usage of arrow functions. And you can have string interpolations, block scope variables, and many more. So if we look back at the example I showed you earlier on, with all this, this is still okay. So now we know for sure that this is a class definition, and we have constructor, and we have a superclass method, well, basically a class method. And more importantly, when we go into extending the class, we now it's very clear that we are extending a superclass using the extends keyword, and we can the subclass has its own constructor, has its own methods, and so on. So for me, this is a really big change. It's a really big improvement over the existing method, and I'm sure most of you would agree. It's the most important part for me is that it's readable. It's now readable. You know what's going on, and then this just works. You use the arrow function, and now this example should now work as we expected to. Now that I've explained to you that how ECMAScript 6 has solved most of the problems in JavaScript, like, so you're probably wondering, like, why do we need TypeScript? Well, TypeScript is essentially JavaScript, but with what I like to call it superpowers. It's essentially a superset of JavaScript created by Microsoft, and the development team includes Anders Helsberg, who most people know as the father of C# and Turbo Pascal. So, being JavaScript, any valid JavaScript is still essentially valid TypeScript, as was explained in the previous presentation. But yeah, TypeScript brings with it additional features, all of which are completely optional. You have type checking, you have interfaces, enums, and generics. And I'm sure that most of these terminologies are very familiar to anyone who's worked with statically typed languages like C# and Java, probably. Yeah. So, but the TypeScript objective is not to replace ECMAScript 6. In fact, one of the design goals is to emit clean, idiomatic, recognizable JavaScript code. And they also said that they want to align with the current and future ECMAScript proposals. So we're not going into a new direction. We're basically just staying on the path while adding upcoming features and providing it to the masses today. For me personally, based on my experience, TypeScript doesn't necessarily mean that you're writing less code. In fact, you might actually be writing a bit more. But what it gives you is essentially the ability to write safer code. And also, I think, once we go through a couple of examples, you guys probably, well, the backend guys will probably feel more comfortable with like JavaScript. I often get asked the question like, oh, why is JavaScript so terrible? Why does it do this? Why does it do that from my backend colleagues? And for the most part, I'm like, well, I don't know. It just does that. I didn't write it. So, one of the cool things I like about TypeScript is, type checking, definitely. And what that allows us to do is to detect problems earlier during the development process. When you, like in this case, this is a simple method definition. I have a method and I have a parameter that I'm expecting to be a string, and it returns nothing. I just have this method that does an alert box, And when I type in like my IDE, I start typing, okay, say hello, and I pass in a string, and all is fine. But as soon as I try to pass in an object, maybe someone who's not completely clear of how this works, could come along and pass in a wrong type of parameters, and things could break, because if you did this, then you would essentially get something like hello and then object or something like that. I'm not sure. I didn't run the test. So this is a very simple example, but as you scale up in your applications, as your application complexity increases, the application becomes more error prone. You're going to run into problems. You might, someone's going to be working on something, and then you're going to be working on something else. Maybe there's a miscommunication somewhere, and then something breaks. Of course, like coding conventions, unit tests, and just sheer discipline can help. But having additional tooling is always good, because you really don't want, you don't want this piece of code to blow up in production, at 5 in the morning because someone decided to check in, like sometimes I do, just before bedtime, and then run deploy for whatever reason. Experience, true story. But and also, like the cool thing is like the type checking also extends to object property checking. So this is another example. You guys get the theme of how it's going to go. So it's a method, and what I'm doing here is that I'm expecting an element of image, an image element or a video element, and then I'm going to attach this this event handler when the object is ready. So, and my definition of ready is that for video elements is like when the video is playable, and for images it's like when the image is loaded. And fortunately for us, like by using TypeScript and using type checking, we can determine that, well, okay, I'm expecting if this element is a video element, then please attach it to the onCanPlay event. Because this event doesn't exist on an image. So if you try to do that, then nothing would happen. And if you did, if you just used onLoad, then the alert box is going to be, the event handler is going to be triggered before the video is playable. So if your objective was to attach the event handler to the element when it's ready to be used, then yeah, that's not the right way to do it. And then the other cool thing that I really like about TypeScript is that it brings to the table the concept of interfaces. You work with a large application, and obviously, naturally, you would have a large team. Again, naturally, you would probably split that job between different teams, like front end and back end, like how we're doing things. And yeah, and one of the tedious things that you would have to do is continuously communicate with the guys. As a front end developer, I have to continuously communicate with the backend guys so that we're both on the same page. Like, I'm going to send you this kind of data. I'm expecting you to give me back this kind of data, right? So by using interfaces, for me, it just it allows me to do something like this. Like, I can the backend guys can define for me the data structure, the structure of the data that they're planning to send to me, and me as a consumer of said data, I already know what's inside, just based on how the just based on using this interface here. So the backend guys would write something like this, like an interface with like server response, and this is another thing that cool thing about TypeScript is that you can use generics, and it has a property called like success, which is a boolean. It could easily be like error message, for instance, or anything you want. And then you have a data of type T, which is the type that you use when you use this generic. And then comes the actual data itself, which contains like a name, the data, and an optional property, which is comments. So in my Ajax request, then I would know for sure that, okay, the data that I'm getting from the backend is going to implement this server response type, and I'm expecting the data to be a user data type. And because of that, I already know that the response object will have a data object inside. There's going to be a data property containing this user data, okay? And I can pass it on to the handler or do whatever I want with it. With the knowledge that these two properties will always be there, and this one might or might not be there. So this eliminates the need for me to repeatedly ask the backend guys, hey, give me the schematics, give me the schema. So, the front-end guys, we don't need to worry about like what the backend not giving us heads up when they change something, like they constantly do. Because like the TypeScript compiler will complain about this. When you try to compile this and the interface has changed, you're going to get like errors everywhere, wherever it's incorrectly used. So again, that brings us back to the whole like early error detection, early problem detection. And then you have Autocomplete Intellisense. So it's been far too long. The front-end guys have been left in the cold when it comes to Intellisense. Sure, I think Visual Studio has a pretty nice tool when it comes to looking up well, implementing IntelliSense for jQuery and all these libraries. But once we start working with like node modules and our components and all of that, we decided that we're not going to include these node modules in our like source control, obviously, for obvious reasons. So I don't know how Visual Studio works exactly, like how the IntelliSense works, but I don't think the IntelliSense would kick in for items that are not included in the project. Maybe someone can correct me on that. But with TypeScript, the TypeScript for the IDE, either Visual Studio, Visual Studio Code, or maybe Sublime or Atom, whichever one. You can use something called typings, well, type definition files, which is essentially like the schema. It provides a schema of the libraries that you're using. So you can include the type definition file for jQuery, like I did in this case, and you get all the IntelliSense that comes with it. And yeah, there's a library, there's a repo on GitHub called DefiniType. Those guys have been working really hard, and they have like over, I think it was 375 library type definition files there. So, if it's there, it's if it's like popular, it's probably going to be defined somewhere on DefiniType. And then so that's IntelliSense. The next part is, TypeScript essentially provides us with future upcoming ECMAScript features today. So in this small example here, I have, this is a small example about the descriptors. Yeah, this one. Yeah. I always get confused with the whole attributes descriptors. I don't know what the correct name is, but apparently it's called descriptors. So what I'm using descriptors for here, and I think you've also seen it in the Angular 2 presentation, is that I have a descriptor that that's called read-only. So what I'm trying to do here is essentially prevent the over here. I want this method here to be read-only. So any classes that extend from that inherits from this class will not be able to override this method. That's what I want. And we can run this example in the TypeScript playground. I hope that works. Yeah. So Microsoft has provided this website where you can test out your TypeScript code, and it compiles to regular JavaScript. How cool is that? So now I have my descriptors here, I have class, and I have a subclass that inherits from the superclass or the base class. And you would expect that, well, in this example, obviously, I already wrote my comments here that this method will not override the base class 1, yes. But we can always, we can't be too sure. Let's check. So, so we get this John Doe. Let's just go back to the example again. Yeah. So over here I have a method, and it will return the first name and last name. That's like the superclass method, the base class method, right? And over here I have a class called fireman. I think it might still be too small, right? And I have a method called full name, which returns the rank, a new property, along with the first name and last name. Yeah. And as the demo demonstrated, that this method here was not able to override this method located within the base class. You can see that? Yeah. John Doe. Okay. So, I think that's pretty neat. Let's just go back to the presentation. Okay. So that's like a brief introduction of like what you can do with TypeScript, and you are probably excited to know, like, how do I get started? You know, it's like well, what you're going to need is obviously an IDE of your choice. I like to use Visual Studio and Visual Studio Code because it comes with built-in support for TypeScript, and then and you can also go to this link over here, which lists down all the IDEs that have TypeScript support, either built-in or via a plugin. And then environment, obviously you're going to need Node.js for compiling the TypeScript down to regular JavaScript or ECMAScript 6, depending on your needs. And then and we have the TypeScript documentation located on typescriptlang.org and type definitions. Yeah, but I'm just going to show you a small example of how you would start a TypeScript project. So I'm going to open up Visual Studio Code. Let me just pull this here. Let's open a folder. I think I'm going to turn around because I'm extending the screen. Let's see, documents. Let's just get a new folder and call it like TS demo. Okay, let's do that. Then, everything's in command prompt. That's huge. Okay, the first thing you're gonna need is obviously TypeScript installed in your machine. So you're gonna need to install TypeScript globally. That I already have it installed, so it's just gonna probably update my local version. Then you can check CSC -3. Check what version you're on. Okay. And then you're going to want to initialize this folder as a TypeScript project folder. And what it does is that it adds this tsconfig JSON file. And this is where you would define all the build options, your configurations, and so on. What do you want to compile as? You can use the various module systems, or you can just go with none if you just want to compile regular JavaScript. Let's go with none. No. And then to build the project, you would run something like this. TSC, build, and then you pass in your current path. So what this essentially tells the compiler is that please build this as a project and locate it at this path. And by default, they'll look for the tsconfig JSON file located in whatever path that you pass in. So we can add a new file here. Let's call it test.ts for TypeScript. And we can simply just define a class and constructor. And we want to pass in, let's say, an element. And that's okay. That's essentially like what JavaScript looks like. The next part is the interesting part, because then you start hanging like, what kind of element, parameter is it? I want to pass in a jQuery object, for example, or I want to pass in a HTML element, and I'm getting all the IntelliSense that I should get. And then once you have that, you can then start doing stuff. You're starting to get IntelliSense, you're starting to get autocomplete for all the properties, all the methods available for that particular type. But that's like, that's obvious, and all IDs can already do that. So you're going to want to install something better. Well, let's say I want to install, this is where typings. You also want to install it using the npm install global typings. What this allows you to do is it allows you to download the type definition files I talked about earlier on from DefiniType and use it in your project. So I think it was something like this. It creates a, yeah, okay, maybe I was wrong. Oh yeah, it was typings, sorry, in it. Okay, so what that did was that it added a typings JSON file. It's kind of like package.json in that it contains all the references to the packages that you are using in the project. And you can typings install save DT for definitely typed jQuery, and for some reason I have to add this. And when you do that, cool things start to happen. So yeah, that saved the saved the reference to jQuery type definition, and it also downloaded the type definition itself. So just to give you a glimpse of what that looks like, it's essentially TypeScript, and this is an interface declaration. So it tells you like what it is with this is like the explanation, what it does, also with the overloads and all that kind of stuff. And the way that you would use it in your project would be something along the lines of this for you guys who work with Visual Studio. I hope you're familiar with this. So we would do typings / index of the ts, something like that. And now, I think that's right. Is it? Yeah, okay. So now, when we declare this as a jQuery type, I'm starting to get IntelliSense, and also autocomplete. And now, I can start to use all the, I get IntelliSense, for all the jQuery stuff. So now it knows that this element is a jQuery type element, and it gives you IntelliSense for what you can do with it. This is nice. Yeah. And then it also tells you that, okay, you're going to need to add something here. I want to add an object. Can I do that? No? First name? No? So it's going to complain that, no, you're passing in the wrong type of parameter here. It has to be a string. Yeah. My class, for example. Yeah. So, okay, yeah, with that. Anyway, yeah, so that's like a really simple example. I mean, when you eventually run the compiler, it's going to produce the same type of output as you would get from the playground. Yeah. Anyway, back to the presentation. So, TypeScript is great and all, but like, what's the catch? Like, what are the disadvantages? What are the problems with TypeScript? It's hard to say what the problem is because TypeScript is essentially JavaScript, so any may be inherited in TypeScript. So and also you need this additional step. But everyone is compiling everyone compiles their project in some way or another. So I think this really is a non-issue. Yeah, but that's my personal experience. Yeah, and anyway, to recap, TypeScript is not a shortcut language. It doesn't deviate from JavaScript. It's not supposed to replace JavaScript. It doesn't go in a different direction. But its purpose is to allow us to write safer code. And it also allows us to use like future upcoming ECMAScript features today, like this. Oh yeah, async and await is pretty cool. But yeah, you're probably going to need like some kind of polyfill when you use it on IE, as usual. And also like TypeScript improves your productivity in the sense that it allows you to detect problems earlier during the development process. And for me, that's very important. And as I've demonstrated with the whole interface kind of thing, you can more or less like decouple from the whole front end, back end thing. Yeah. And also, I personally think, and I hope you guys who work with the backend also agree that that TypeScript can provide an easy transition for backend developers who are interested in front-end development, but don't go into it because no JavaScript. Oh God, why? Well, that kind of thing. But with TypeScript, I really think that that's like the bridge between the backend and the front end for backend developers. So if you're a backend developer, and you're interested in front end development, I really recommend that you look into TypeScript because it's really great, and I think you're going to enjoy yourself working with front end development and using what you're very familiar with. That is it for my session. Thank you for listening, and if you have any questions. And I'm just going to leave this here for anyone interested. You can contact me at that email, or you can just come up to me and give me your business card or something. Yeah. Yes?
I got a question.
Yeah.
I'm not often speak with things, perhaps late question. But do you see any movement in there are libraries or frameworks or TypeScript first? So far, I've seen more or less like catch up and final touches.
Well, Angular is one of them. Like the previous, like the previous presentation has demonstrated, Angular is one of those libraries that was written in TypeScript.
Okay.
Yeah.
Yeah, I missed that.
Yeah.
More than I expected.
I started writing all my GitHub repo plugin stuff in TypeScript now. So yes, please.
Two questions. One very short one. So I assume that when you use some old JavaScript library which doesn't have a type definition, the only downside is that you don't get the IntelliSense.
Yeah, exactly. Yes, that's true. But you can easily write your own. Or if you don't want to do that, then you can just do something like, let me just. If you're using like some kind of a plugin, which you can do something like interface jQuery, and then my plugin function to stop this guy from complaining. So now I can do something like this.
Oh, but if I'm too lazy to write this interface thing, so can I still use it?
Yes, you can use it. It might still it might complain though when you compile. It'll probably just say something like, "Well, we don't know what this is."
No, but is it a warning or is it error?
I think you can set that up in the configuration whether to blow up or not.
Right.
Okay. Yeah, but just like in this small example here, let's say if I were to comment this out, then this is what you're going to be getting. So it's probably worth to just add this guy because it's just like one-liner. And it doesn't really care like what you do inside it. It's just, you're basically defining it as a function. What kind of function it is? Well, I don't know.
All right. And now, when you have to debug this thing, for example, in the browser developer tools, do you see the original source or do you see this compiled JavaScript?
Depends on how you set up your compiler. If you use if you do source mapping, then this is going to work out okay for you. If you don't, then you're going to see a bunch of JavaScript
there is
like this guy here. Yeah, all of that, and that's probably what you're going to see instead if you don't use source mapping. and you should.
Well, but it's possible to use source map, right?
Yes, yes, of course, yes, it's definitely possible. Yeah, I think yeah, if I'm not mistaken, the compiler has an option for generating source map like built in. So you just tell it I want source mapping and set source maps to true, and when it compiles, it will also generate a source map for the generated file. Yes, please.
What would you recommend to use to generate the classes using the server side to use the same class?
Yeah, I know. That's actually a really good question. That's a question I asked myself. Like, how can I generate the interface automatically from the classes that I already have? Because I don't want to do the same work twice. I completely understand your concern, and that's actually one question I have no answer to. Because unfortunately, yeah, it's a really good question, and I really hope that Microsoft guys would come up with something. Like, we have a class here, and please like have some kind of a tool that generates the interface for this class. That would be great, but as it is today, I really don't know. Sorry.
We also have a special tool for that, but
Okay.
maybe we have a chance to test it.
Yeah. Okay. Awesome. That's great. Yeah, they have a tool for that. I would love to look into that. Yes, please.
I have a very specific question.
Okay.
Can you use closures with TypeScript?
Closures. I honestly don't know.
Last time I tried, I
Yeah.
had very bad errors with return types, so basically I can't just return a function which returns something else.
Okay. Yeah, that's a
Maybe
good question.
you
How
know.
would you do that? I'll look into that. Thank you. Thank you. Yeah. And you've given me something to think about. Yeah. Okay. Yeah.
You
Yes,
definitely can use closures,
Oh, yeah.
and well, I guess if my definition of closure is the same as yours, then you're using just like in JavaScript. So closures are.
So you're
Yeah.
saying if I can just return a function which returns something else?
When you
and-
need something else.
For example, I return a function which returns a number.
Yeah.
And when I use this with global function, I can just use it like number.
It should be possible. Let's talk about.
Yeah, yeah, actually, yeah, we could probably discuss that afterwards. Just experiment with it, with the playground or something. Okay. Yes, last one, I hope.
If I like some JavaScript library and I would like to use it in as TypeScript library, what
Okay.
is my steps to do? But that is not
I think it was the same as the previous questioner. That if you wanted to use a library which doesn't already have its own type definitions, then you can either write your own, or like I did over here, just do something like this. But
the existing tools for doing the
to creating the type definitions, I don't think so. If it was written in TypeScript, obviously there would be. I think there is an option for the build configuration file that you can automatically generate the type definitions based on your TypeScript files. But for plugins which, like old plugins or existing plugins which have no type definitions, then I'm sorry, but you're kind of out of luck. But have a look at the definitelytyped.org, because chances are the library that you're using, if it's a kind of relatively known library, like well-known library, then chances are the type definition file is going to be there. Just have a look. Oh, okay.
Do you have Windows and an Apple computer?
This is an Apple computer, but I'm running Windows. Yeah, I love the hardware, but macOS is not for me. Sorry. But yeah, we do have Intellisense here. It is running on a Mac, and so yeah.
Okay, thank you very much.
Great.